Well, hi, this is Bob, and we're getting ready to take a look at section 3.2. This is on solving linear equations, and it starts over on page 168 in chapter 3. The first thing I wanted to make mention of here is that we have solved some equations like maybe 2x minus 1 equals 5. And when we go and solve that, we get 2x equals 6 or x equals 3. Okay, and we have literally probably done 100 of these throughout chapter 2, and they basically involve the four main solving patterns that we developed as we worked our way through the chapter, and then we also worked our way through inequalities, basically using the same skills, only being cautious with the arrows. Anyway, what I'm trying to point out here is when we graph this type of an equation, we used a number line, and we were able to graph that one point on the number line that x was the solution for x. And of course we could plug x back in and show that this is indeed the answer. Well, it turns out when we have in coordinate axis system, which we've just introduced and looked at some properties of, that remember we're going to have some type of a graph involving x and y, and where in this particular equation, the one I just worked and got an answer of 3, we have one unique answer. But when we have an equation in x and y, maybe something like x plus y equals 5, well, it turns out that there's a whole bunch of numbers that would satisfy that equation. And so instead of getting one unique point, we actually get an infinite number of points that would solve that equation or satisfy the equation. For example, here x plus y equals 5. We don't show all of them, but what we try to do is derive the line or the graph that they lie on. And just to give you a few numbers that add together to 5, if x were 0, then y would equal 5. And if x were 1, y would equal 4. And if x were 2, y would equal 3. I'm a little off my graph here, but I'll tell you what I'll do. I'll let x equal, this is x equals 1. There's x equals 0 and y equals 5. This was supposed to be x equals 1, y equals 4. This is x equals 2, y equals 3. How about if we let x equal 5? Well, then 5 plus 0 equals 5, so that would be right here approximately. And of course, we could let x equal a negative 1. And if x was negative 1, we'd have negative 1 plus y equal 5, or adding 1 to both sides, y equals 6. So here you can get an idea, and normally what we do after we get a few points is we hook them together with a line, and this defines the graph of x plus y equals 5. Okay, well, I wanted to point that out or relate what the book started off with at the beginning of this section here, and relate it to a number line where we got one unique number graph, like in the case I showed we got 3, and when I graphed x plus y equals 5, I put some of the points on the line that satisfy that equation, or I defined by that equation, but everywhere on this line, which is made up of an infinite number of points, the xy pair satisfies x plus y equals 5. Again, 1 and 4 are 5, 2 and 3 are 5, 5 and 0 is 5, negative 1 and 6 add up to 5. So it turns out that there's an infinite number of solutions to x plus y equals 5. And that's one of the differences between when we're graphing on a single number line and then the xy axes. Now, here is their presentation. We'll look at a little bit of theirs. The only thing is they're not going to do the graph here. Okay, but I wanted to relate that to the graph because, of course, that's what their next topic is going to be when we get into 3.3, and it's nice to lay a little groundwork early on. Here's their equation on the top of 169. It's 2x plus y equals 3. Now, the first thing that they do is we know that there are some ordered pairs, and of course always the first one is x, and the second in the ordered pair is the y value. And the first thing that they do is they tell us that that we have two variables instead of just one, and one of the solutions to that would be x equals 2 and y equals -1. In other words, they just told us this, and we can plug in 2 for x, and we can plug in a -1 for y, and this would be 4 minus 1 or 3. And of course, 3 equals 3, so indeed 2 minus 1 is a point that satisfies that equation. But then they go and tell us that there's some other points. They say, well, what about 0 and 3? And if we were to plug in 0 and 3 into the equation 2x plus y equals 3, then letting x equal 0, we get 2 times 0, and then letting y equal 3, and sure enough, that equals 3 also. So it turns out that not only 2 and -1 satisfy this equation, that same 2x plus y equals 3 equation, but also 0 and 3 satisfy the equation. Well, they give us one more. I'll put it on the top of the next page. You can follow along, or I'm just doing, trying to warm up like the bookworms up here. They give us 5 and -7. Here's our original equation. And they say, well, also 5 and -7 satisfy that. Okay, now remember, when we had that number line, that first example I did, we got only one answer that worked. And now when we're dealing with an XY axis, we're finding out that there's all kinds of numbers that could satisfy the equation. Okay, so anyway, when just as they do, we'll put in 5 for x, and then I'll put in -7 for y, and sure enough, that is equal to 10 minus 7, or 3. So we have seen 3 ordered pairs that work, and I can assure you that there are an infinite number, millions and millions of ordered pairs that satisfy or are defined by the graph of 2x plus y equals 3. Okay, well, they could have actually stuck together 3.2 and 3.3, but I like their approach of getting us used to plugging in and evaluating. And what they're going to do in example 1 now on the bottom of 169 is they give us a new equation, 2x plus 3y is equal to 6, and they want us to find out when x equals 0, what does y equal? And when x equals, and when what does x equal when y equal 1? And what does y equal when x equals 3? Okay, and so what they're doing is, instead of us just having find one, either all x's or all y's, they want us to find a combination of x and y's. In other words, this is to evaluate the equation. So to do the first one here, I'll call this number 1. When x is equal to 0, let's see what y equals. So I let x equal 0, and 2 times 0 is 0, so it basically drops out of the equation and gives me 3y equals 6. Well, then when I divide by 3, I get y equals 2. So we would have the point 0, 2. That is definitely on the equation. I'll finish this off on the top of the next page there, or the next screen. Now the next thing they want us to do is find x when y is equal to 1. So we take this 1 and plug it in for y. And that would give us 3x plus 2 times 1 equals 6. Okay? Then the next thing that we would do is that would be 3x plus 2 equals 6. Then we would subtract 2 from both sides. Hope I didn't copy that wrong here. 2x plus 3, you know, sorry about that. Sometimes I get a little, I just write the problem backwards. 2x plus 3y equals 6. Okay, at least I caught myself before I went through the entire question. Okay, so we were supposed to find x, 1, and we still let y equal 1. So we would have 2x plus 3 times 1 equals 6. And that would be 2x plus 3 equals 6. Then we would subtract 3 from both sides. And that would give us 2x equals 3. And x equals 3 halves. So our ordered pair then would be 3 halves and 1. They gave us the 1 and we plugged in and found out that x is 3 halves. Well, let's do that last one of theirs too, and I'll make sure to copy the equation correctly this time. Okay, the last one is 3y, and what that means is they want us to find out what y is when x equals 3. So we're going to substitute 3 in for x, and then solve algebraically for y. This would be 6 plus 3y equals 6. Then we subtract 6 from both sides. 0 plus 3y is just 3y, and 3y equals 0. When we divide both sides through by 3, we're going to get 0. Remember, we can divide into 0, but we can't divide by 0. So y equals 0. So that ordered pair, I'll write it right underneath the one where they gave us the 3y. That one would be 3 comma 0. In other words, we already knew that the x value was 3, and we plugged it in and found out the corresponding y value was 0. Well, that's pretty much it for this skill in this chapter here. I'll work a couple of more questions. I think I'll work example 2, and then I'll take a look at example 4. And then I have a couple of homework questions picked out, a few homework questions picked out, and I think that will be enough to get the idea of what they want us to do in this section here. Okay, let's take a look at example 2, because some of the homework problems are set up like this. Now in example 2, they're getting more like we'll be doing later in the chapter. We have like a little diagram for x and y here, and we want to know when x is 0 what y is, and when y is 2 what x is, and when y is 0 what x is, and when x is minus 5 what y is. In other words, this problem, this skeletal arrangement right here, is basically telling us 0 y and x, 2, and then the third one there is when y equals 0, what does x equal? And then the last one is when x equals minus 5, what does y equal? Okay, and that is exactly like we had with the question we did before, only we've got it organized in kind of a table here. So let's find out. The equation, by the way, is 2x minus 5y equals 20. Okay, and the first thing we're going to do is we're going to put in, and this is, since this is done down below there, I might shortcut this just a little bit. We're going to put in 0 for x, And of course 2 times 0 is 0, and it drops out, and that gives us minus 5y equals 20, or dividing both sides by minus 5, we get minus 4 for y. And that would be our first one. Okay, then the next one tells us to go back to that same equation, 2x minus 5y equals 20, but this time we're going to put in 2 for y and solve for x. Okay, and this would give us 2x minus 10 is equal to 20. When we add 10 to both sides, that would give us 2x equals 30. And then when we divide both sides by 2, that would give us x equals 15. Okay, so here's the first two of those questions done on example 2. I did A and B, and I will let you take a look at C and D there, or the last two. You can follow along with their steps when they plugged in x is equal to, or when y was equal to 0, and what x was turned out to be 10, and when x equals minus 5, it turned out that y was negative 6. Okay, well here's the last thing before we go do some look at some homework questions together. Okay, this one, it says testing solutions, and we just hinted at this a little back in the previous section, where we found out if a number was if a coordinate was on the line. Remember what we did is we plotted a few numbers and we ended up with a line, and then we asked ourselves if a certain point was on the line, and if it was, we said yes, but there was also a point that was not on the line, and we did that by inspection. We drew the line first and then checked to see if the points that they gave us were indeed on the line. One of them was and the other one wasn't. Well, this would be a way to do that same question without actually drawing the graph. So here's our equation. Y equals 3x plus 2, and what we want to do is they've given us 3 ordered pairs there, and we want to know if those ordered pairs satisfy that equation. So I'm going to write the ordered pairs first. 2, 3, 1, 5, and minus 2, minus 4. Now, just again, to give you the graphical significance here, if the equations work, in other words, I'm sorry, if the coordinates work, when we plug them in, we get a true statement, that means that that point would be on the line of that graph. Okay? So anyway, let's do the first one, 2, 3. So y, of course, remember the first one's always x, and the second of the ordered pair is always y. So 3 does 3 equal 3 times 2 plus 2? Well, that would be saying that 3 equals 6 plus 2, or 8, and that is certainly not true. That's false. 3 is not equal to 8, so the point 2, 3 is not on that graph. Or for right now, all we can say is it does not satisfy the equation y equals 3x plus 2. Well, now let's plug in 1 for x and 5 for y. Is this a true statement? Does 5 equal 3 times 1 plus 2? Yes. That would give us 5 on the left equaling 5 on the right. So the coordinate 1, 5 satisfies that equation, and that's also another way of saying that 1, 5 is on the graph. Whatever that graph looks like, 1, 5 is on it. Okay, the last one, let's plug in negative 4, negative 2, and see if that makes a true statement. Does negative 4 equal 3 times negative 2 plus 2? I'm plugging all of these, of course, back into this same original equation they gave us. And so we're asking, does minus 4 equal minus 6 plus 2? And minus 6 plus 2 is minus 4, so minus 4, of course, equals minus 4. So the point minus 2 minus 4, which is another way of saying when x equals minus 2 and y equals minus 4, since that satisfies the equation, then that point would be on the line if we had been able to graph that line at this point in time. So the 2, 3 didn't work, but the 1, 5 and the minus 2 minus 4 did satisfy the equation. Okay, well, I have a few questions just for us to look at, a few examples from the homework, and I think you'll find the this section pretty straightforward in terms of instructions and a good support from the examples in the text also. And of course you have your solution key to check with. Okay, so let's see, let's start off by looking at number 2, which is 3x minus y, kind of like what we just did in a way. Oops. 3x minus y equals 5. And they want us to find out when x is equal to 0, what is the y value, and when x is equal to 1, what is the, excuse me, when x equals 0, what's the y value? Did I goof that up there? 0, yes, okay. When x equals 0, what's the y value? When x equals 1, what is the y value? And what is the x value when y is equal to 5? Okay, I will tell you that we normally plug in x's to look for y's, but they're showing us here that we can also look for the x's. Okay, I'll start off with this by plugging in 0 for x. And 3 times 0 is 0, so that would leave us minus y equals 5, which is the same as minus 1 times y. And as I mentioned earlier, I get rid of the minus 1 by dividing both sides through by minus 1, and y would equal negative 5. So that's my first answer, and it would be when x equals 0, y equals minus 5. Now, the next one wants to know what would y equal when x equals 1. So I plug in 1 into that same equation, and this would give me 3 minus y equals 5. Then I would subtract 3 from both sides, and that would give me minus y equals 2. And when I divide both sides through by minus 1, I would get y is equal to negative 2. Okay, and I'll bring the last one up onto the top of the next screen here. What we're going to do is plug in 5 for y and find out what the x value would be. Here's what we're doing here. Okay, 3x minus y equals 5, and we're going to plug in 5 for y. So 3x minus, remember here's where y goes, and that's where we're going to put the 5, equals 5. So that would be 3x minus 5 equals 5. Then the next thing we're going to do is add 5 to both sides. That gives us 3x equals 10. And then finally divide both sides by 3. And we get 10/3 for the x value. Okay, let's take a look at question number 22. We've done the ones with the little tables here. I just finished one of those. Let's take a look at 22. '22 says 3x plus 7y equals 21. Okay? And what they want to know is we're supposed to, for the example, tell which of the given ordered pairs are solutions. Okay, so we've got, here's what we're going to be evaluating. 0 and 7, 0, 7, 7, 0, and 1, 2. In other words, we're going to check and see if those equations, if those points, those xy points, coordinates, satisfy the equation. And again, just to remind you, if they do satisfy the equation, then whatever the graph of 3x plus 7y equals 21 looks like, those points will be on the line or on the graph. Let's start off with 0 and 7. So it would be 3 times 0 I'm just making sure I copied this right. I've had a problem with copying. See? Okay. I made a mistake. The first one is 0, 3. Okay, so my mistake there. So let's plug in 0, 3. And then the next one, just to make sure, was 7, 0, and 1, 2. Okay. So 3 times 0 plus 7 times 3, does that equal 21? Well, 3 times 0 is 0, so it would drop out, and that leaves a 7 times 3, which is 21, indeed equals 21. So 0, 3 would satisfy the equation. Let's plug in 7, 0. That's the second one here. I'll write it down below here. 7, 0, and see if it works. Does 3 times 7 plus 7 times 0 equal 21? Okay, so 3 times 7 is 21, and 7 times 0 is 0, and 21 and 0 is indeed 21. So far we've got the point 0, 3 and 7, 0 both working. And then the last one we're going to take a look at is 1, 2. Okay, that means we plug in 1 for x and 2 for y and see if we get a true statement. So this would be 3 times 1 plus 7 times 2, and does that equal 21? This would be 3 and 14. No, 17 is not equal to 21. Therefore, the point 1, 2 does not satisfy the equation. And what that means graphically would be that it's not on the line. Okay, I thought I'd do one more of these, and then you'll be more than ready to do the homework problems. Here's the last one. X minus y equals 1. And this is question number 28. And I chose this one just because we have to be a little more careful with the minus sign there. And here are the 3 points they want us to evaluate. 0, 1, 0 minus 1, and 1, 2. Okay, so let's start off with 0, 1. When x is equal to 0 and y is equal to 1, does that make a true statement? In other words, does minus 1 equal 1? And of course the answer is no, so that means that it's not equal to, minus 1 is not equal to 1, so that means that 0, 1 is not does not work, and we would not list that as the answer. We're supposed to list the ordered pairs that satisfy the equation. Okay, how about 0 minus 1? So I'm plugging x for 0 for x again, minus a minus 1 parentheses are helpful. Let's see, this would be 0 minus a minus 1, which actually turns to plus 1 equal 1. So 1 does equal 1, so the point 0 minus 1 does work. Okay, then the last one we're going to plug in 1 for x and 2 for y. So does 1 minus 2 equal 1? Well, actually, 1 minus 2 is minus 1, and minus 1 is not equal to 1, so the point 1, 2 does not satisfy. Okay, well, that's a really good start for what's coming up next, because we actually, in section 3.3, come back to the graph, the coordinate axes that we saw before, and we're actually going to start drawing some points on the graph, and we've got some more keys to the overall idea of graphing now. I will be back shortly with 3.3. Thank you.